last class, we have seen a direct approach based method, and initially I introduced this method, and we have seen that you can actually form two matrices, which we call it as actually BI-BC matrix, which is bus injection to branch current matrix, which converts your bus injection to directly into branch current. So, basically it is similar to your backward sweep, and then we form another matrix which is called as BC-BV matrix, which basically converts your branch current to bus voltages, and this is nothing but similar to your forward sweep. And we have seen that if we get this is equal to, means if you multiply this BC-BV multiplied by BI-BC multiplied by your I node, you can get the voltage difference, and this voltage difference we have seen that it is basically V1 minus V2, V1 minus V3, and it will go up to V1 minus Vn if there are n number of nodes into the system. So, we can get the voltage difference with respect to your first node, and this collectively we called BCBU multiplied by BIBC, we call it as matrix DLF, which is multiplying by, if you know matrix DLF, we can directly multiply it by I node, which are basically nodal currents, we will get voltage difference. Now, let us see how we can get this BIBC and BCBU matrices from your system data. So, let us say you are having this system data, similar system data which you have considered for backward forward sweep algorithm. I have taken it here, and as I told you, these are actually branch numbers. So, this is branch number 1, branch number 2, branch number 3, branch number 4, and this is branch number 5, and their connections. So, starting bus and ending bus is given in these columns. Their impedance, that is resistance and reactance, is given in this column. So, this is nothing but your impedance of a line section which is between 1 and 2 node. So, as I told you, we call it as a line data, and this is nothing but your load which is connected at any jth bus. Now, to form your BIBC matrix, which is basically bus injection to branch current matrix, where we want to convert your bus injection to branch current. So, what we can do to form it, let us say this is corresponding to bus number 2, 3, 4, 5 and 6. So, here I am giving this as a bus numbers, and here I am giving your branch numbers. So, branch number now between 1 and 2, and then it is between, there is between 2 and 3, 3 and 4, 4 and 5, and then 3 and 6. So, you have to build the logic to build this BIBC matrix directly like this. So, here since this node 2 is connected to node 1, let us say I am putting 1 here, and it is not connected to other nodes. So, 0 0 0 0. Now, if there is connection between node 2 and node 3, means if there is connection between node 2 and node 3, what you have to do, you have to copy this column and put it here. So, I will just copy and put as it is, since there is connection between 2 and 3. So, it is copied and pasted here, and then it is nothing but branch 2 and 3. So, at branch 2 and 3 I need to replace it by 1. So, this will be replaced by 1. Similarly, next time if you go to next section, if there is connection between 3 and 4, we know that there is connection between 3 and 4. So, what you have to do, you have to copy the column corresponding to 3 at 4th location. So, here I copied this column as it is, and since this is 3/4 branch, so at row number 3 4 we need to put 1. So, here at 3, since it is 3/4 branch, we need to put 1 here. Now, see next step, that is see the connection between, there is connection between 4 and 5. We know that there is connection between 4 and 5 here. So copy the column corresponding to 4th node in 5th location. So 1 1 1 0 0, and since this is corresponding to branch 4 5, at the branch 4 5 we need to put 1 here. So here, since it is corresponding to branch 4 5, we need to replace it by 1 here. Now there is no connection between 5 and 6. So here the connection is not between 5 and 6, but however there is connection between 3 and 6. So there is actually connection between 3 and 6. So what you have to do, you copy the column corresponding to 3 at 6th location. So here I copied that column as it is, and since it is 3 6, branch number 3 6, so wherever the branch number 3 6 is coming, at corresponding location we need to replace this entry by 1. So this entry will be replaced by 1. So you can see that by building this logic into your program, you can automatically build your BIBC matrix directly. Now let us see how we can build your BCBV matrix. So we have seen that your BCBV matrix converts your branch currents to your bus voltages. So here therefore we need to write bus voltages. So bus number 2, bus number 3, bus number 4, 5 and 6, and here there should be branches. So it is actually 1 2 2 3 3 4 4 to 5 and 3 to 6. Now since there is connection between 1 and 2, here we need to put the impedance of this branch Z12 into this column, because 1 2 is connected to 2. Now there is no connection between other branches, so here there will be 0. Then you have to see the connection, if there is connection between 2 and 3. So copy the column, copy the row corresponding to 2 and put it at row number 3. So it will be Z12 0 0 0 0, and since it is actually branch 2 3, we are considering it here at 2 3 location, we need to replace it by your impedance of 2 3. So it is actually impedance of 2 3. Now let us see another case where there is connection between 3 and 4. So what we would do, copy the row corresponding to 3, put it at 4th location. It will be Z12 Z23 0 0 as it is. I copied it. Now this is corresponding to branch 3 4, because we are considering branch 3 4 here. So at branch number 3 4 location, we need to replace it by impedance of 3 4. So it will be Z34 here. Now for branch number 4, node between 4 5, there is branch. So copy the row corresponding to 4th node and put it at 5th location, because there is connection between 4 and 5. So it will be Z12 Z23 Z34 0 0, and it is 4 5, branch number 4 5, at 4 5 location we need to replace it by impedance of 4 5. So this is Z4 5. However, there is no connection between 5 and 6. So but there is connection between 3 and 6. So what we need to do is copy the row corresponding to 3, put it here, Z12 Z23 0 0 0, and since it is branch number 3 6, at branch number 3 6 location, put the impedance of Z36. So this is how we need to build your BCBV matrix and you need to build the logic based on this particular process, and once you build the logic you can directly get your BCBV matrices. Now let us see how we can use this for unbalanced system. So in case of unbalanced system, so for unbalanced radial system, so here we are not considering till now weakly mesh system. So in case of unbalanced radial system, let us consider this unbalanced radial system. Let us say this is your branches between 1 and 2, then between 2 and 3, 3 and 4, 4 and 5, and then there is 6 here. So here it is 1A, 1B, 1C, this is 2A, 2B, 2C, this is 3A, 3B, 3C, 4A, 4B. Here we are considering only 2 lines which are going ahead. So only 2 phase system is here, and here only single phase system which is going ahead. So here we are having phi A, and here since it is actually C phase here, so it is actually 6C. So it is branch bus number 6 we are considering it here. So in this case also we can use exactly similar logic, build your matrices. So whenever you are building your BI BC matrix, we need to put node numbers here. So here the node numbers are corresponding to 2, 3, 4, 5 and 6. Since in at bus number 2 we are having all the 3 phases A, B and C. Similarly at bus number 3 we are having all the 3 phases A, B, C. At 4 we are having 2 phases A and B. At 5th we are having only 1 phase, that is A, and at 6th we are having only 1 phase, that is C here. And here we are having this line numbers. So these line numbers we note from 1 to 2, this is from 2 to 3, this is from 3 to 4, this is from 4 to 5, and this is from 3 to 6. So for 1 to 2 all the 3 phases are existing, so A, B, C. From 2 to 3 again all the 3 phases, so A, B, C, and from 3 to 4 you are having only 2 phases A and B, and at between 4 and 5 you are having only 1 phase, that is A phase, and between 3 and 6 we are having only C phase. Now here similar to your earlier BIBC matrix which you have considered for single phase equivalent system or balanced system, in unbalanced system, here since there is actually 1 and 2 they are connected, you have to put the unity matrix here, which is basically like this. 1 and 2 they are connected, and all other columns will be 0 0 0 like we have put for balanced system. Now since there is, if you have to see the connection between 2 and 3, there is connection between 2 and 3. So what you have to do is copy the column corresponding to 2 and paste it at location 3. Since all the 3 phases are existing in 3, so we need to copy all the 3 phase columns, that is ABC columns, and put at ABC locations, the 1 0 0, 0 1 0, 0 0 1, and then I just copied it as it is. And the next step is since it is connection between 2 and 3, so at columns or rows corresponding to 2 and 3, it should be replaced by unity matrix inside this one. So here this will be replaced by your unity matrix here. So it will be 1 1 1 here. Now see the connection between 4 and 3 and 4. Since there is connection between 3 and 4 here, we need to copy the column corresponding to 3, but only there are actually A and B phases. So, copy the column corresponding to A and B phases, input at 4th node location, that so it is 1 0 0 1. So, I am just copying this column here and this column here, and then you are having 0 0 here, and then 1 0 0 1 0 0 0 0 0 0. Okay. And then next step, as I told you, since it is we are considering this 3-4 branch. So, at 3/4 row we need to put a unity matrix, but since there are only 2 phases, we have only unity matrix of 2 by 2 size. So, here we need to put 2 by 2 matrix. Now, there is connection between 4 and 5. So, copy the column corresponding to 4. However, there is only A phase is exchanged. So, copy the column corresponding to A phase, put it here. So, here 1 0 0 1 0 0 1 0 0 0. And the next step, as we know, since this is branch number 4 and 5, at 4 and 5 we need to put unity matrix. Our size of this is only 1 by 1. So, we need to replace this entry by 1. Now, there is no connection between 5 and 6, however, there is connection between 3 and 6 which you are talking about. So, copy the column corresponding to bus number 3, however, only C phase is existing here. So, we need to copy the column corresponding to C phase, so which is basically this column here. So, if I can copy it as it is, so it will be 0 0 1 0 0 0 0 as copied column. And then since we are talking about branch number 3 6, at branch number 3 6 location we need to put unity matrix, but here since the only C phase is existing, unity size will be 1 by 1. So, this is how actually we have to build your BIBC matrix for 3-phase system. And if you compare of BIBC matrix of similar system, we have considered balanced 6 bus system and this unbalanced 6 bus system. You can see that structure is similar, only in this case we are getting the matrix depending upon. So, instead of 1 here, since there are actually all the 3 phases existing between 1 and 2, we are getting 3 by 3 unity matrix. Here again between 2 and 3 again we are having all the 3 phases. So, we are getting here 3 by 3 matrix. Here between 3 and 4 only 2 phases are existing. So, it will be actually 2 by 2 matrix, and here only A phase is existing and here only C phase is existing. So, we are getting 1 by 1 unity matrix here. So, this is how we can build your BIBC matrix. Let us see how we can build your BCBU matrix. So, BCBU matrix for 3-phase system. So, in this case we have seen that here that there will be bus numbers 2, 3, 4, 5 and 6, and here there will be branch number. So, there is band between 1 and 2, 2 and 3, 3 and 4, 4 and 5, and then there is 3 and 6. So, in this case we need to copy the row. So, here we, in case of BCBU matrix, we need to put the impedances. So, here the impedance matrix, first we will start with 1 and 2, since it is connected to 2, we will start with impedance matrix of 1 and 2. So, it is actually Z AA, Z AB, Z AC, Z BA, Z BB, Z BC, Z CA, Z CB and Z CC, and since it is corresponding to 1 2, so these are actually basically branch number 1 between 1 and 2. So, branch 1 2 we can write it here, and it is not connected to anywhere. So, all the other entries will be 0. Now, similar to your BIBC matrix, we need to see the connections. So, here there is connection between 2 and 3, which is basically this, and all the 3 pages are existing. So, copy the rows corresponding to 2, since there is connection between 2 and 3, put at third, since we are in this case we are not to copy all the 3 phases. So, it is again Z AA, Z AB, Z AC, Z BA, Z BB, Z BC, Z CA, Z CB and Z CC, and just I am copying it as it is. So, it will be 1 2 1 2 everywhere, and this, since I am copying it as it is, it will be like this. So, I just copied, since there is connection between 2 and 3, row corresponding to is copied at bus number 3, and then next step we know that we need to replace this part by impedance of 2 3, because we are talking about line number 2 3. So, this is actually line number 2 3. So, here we need to put the impedance of 2 3. So, again here all the 3 phases are existing. So, AB Z AA, Z AB, Z AC, Z BA, Z BB, Z BC, Z CA, Z CB and Z CC, and this is corresponding to branch 2 3. So, it will be 2 3 here. Then there is, see the connection between 3 and 4. So, only 2 pages are getting connected between 3 and 4. So, in this case, so this is corresponding to ABC pages as I told you. So, ABC, AB, A and C, and this is corresponding A, B, C, A, B and C, A, B, A and C. So, rows corresponding to A and B phases only need to be copied and pasted it here. So, here it will be 1 2 AA, 1 2 AB, Z 1 2 AC, Z 1 2 BA, Z 1 2 BB, Z 1 2 BC, which is copied A and B rows. Similarly, here we need to copy this one. Z 2 3 BA, Z 2 3 BB, Z 2 3 BC, and as it is. And as I told you, next step is, since it is branch 3 4, we need to put at this location, we need to replace this by impedance of branch 3 4, since there are only 2 pages are existing between 3 and 4. So, it will be just 2 by 2 matrix. So, Z AA, Z AB, Z BA and Z BB, and since it is of 3 and 4, so we need to put 3 and 4 here. Then we can see there is connection between 5 and 4. So, but only A phase is existing. So, column, so row corresponding to A, copy it and paste it here. So, Z 1 2 AA, Z 1 2 AB, Z 1 2 AC, Z 2 3 AA, Z 2 3 AB, Z 2 3 AC, Z 3 4 AA, Z 3 4 AB and 0 0. So, I just copied this particular row and pasted it here, and as I told you, next step is basically, since we are talking about branch number 4 5, we need to replace this entry by impedance of 4 pi, and 4 pi only one phase is existing. So, therefore, there will be actually 1 by 1 matrix. So, it will basically 4 phi AA. Now there is no connection between 5 and 6, but there is connection between 3 and 6. So, in this case we need to copy row corresponding to 3. However, it should be actually a C phase, because here we are getting only C phase which is connected to C phase of bus 6. So, copy C phase entries of third node here. So, 1 to CA, Z1 to CB, Z1 to CC, Z23 CA, Z23 CB, Z23 CC, 0 0 0 0, and since we are talking about line between 3 and 6, which is this particular entry need to be replaced by impedance of 36, that is basically Z36. So, this is how actually you have to build your BCB matrix. Again, structure is, if you compare the structure of balanced system and unbalanced system, it is similar. So, this was the matrix which you have got for balanced system. So, only thing is, so whenever there is all the 3 phases exist in this section and in this section, so these entries will be 3 by 3 entries. So, we can see that here we are getting these entries which are basically 3 by 3 entries, and then here we are having actually this basically entry is 2 by 2, because we are having only 2 branches here. This entry will be 1 by 1 because only one phase is existing here, and this entry will be again 1 by 1 because only one phase is existing here. So, we can see that these BCBV and BIBC matrices can be easily built by knowing your system data. So, here from knowing these connections, or you can say from the line data, we can build your BIBC matrices and BCBV matrices. Okay, so in today's lecture, we have seen how to get your BIBC and BCBV matrices from the configuration of the system, or if you know the line data of the system, how we can get BIBC and BCBV matrices. We have seen how the logic is formed, and based on this logic we can develop your code and build BIBC matrices. So, basically in today's lecture we have seen how to get these BIBC and BCBV matrices for radial balanced distribution system and radial unbalanced system. So, we have formed, so we know that once you get this BIBC and BCBV matrices, you get your what is called as distribution load flow matrix, and how we can use this load flow distribution load flow matrix for solving the load flow. We will see in next lecture, which is basically based on step by step process of this algorithm based on direct load flow approach. Thank you.